Good afternoon, guys. We're doing lessons 101 and 102 today. So 101 you'll do the odds on, and 102 you'll do the evens. So the first thing we're going to do is look at proving that the derivative of sine of x is equal to cosine of x. So we're going to first of all look at the limit as x approaches 0 of sine of x over x. So now if you'll put that in your calculator, put in y equals sine x parentheses divided by x sorry, I had a bunch of stuff in my calculator, gotta delete it. Alright, sine of x divided by, delete that, divided by x. Alright, so what I've got in there is that, and I'm going to go back and I'm going to make sure that my mode is radians. It's not, it's degrees, so I'm going to change it to radians. And then I'm going to go to the table, so second table set, and I'm going to start it at 0.1, and delta table is going to be 0.01. Okay, now we're going to go to table. We're going to look at those values when it gets closer and closer and closer to 0. You can see what's happening. It's getting really, really close to what value? Right, so it's getting close to 1. So it's approaching 1, isn't it? All right, so because this is a geometric proof, what we're trying to show is that cosine of x is less than the sine of x over x, which is, now we know, less than 1. All right, so now if you look at the pictures down at the bottom of page 516, there's a triangle with an area inside of each one of those. And the one on the left, area 1, is the largest because it's solid. The whole thing is filled. And then area 2 is the next largest. And then area 3. So we know that area 1 is greater than area 2 and that that's greater than area 3. And if you look on page 517, they go through and they show you the area of each triangle. So if you're looking at the first triangle, the area of that triangle is 1/2 the base, which is 1, because they tell us that it's a circle with radius 1, times the height, and the height is the same as the tangent of x, opposite over adjacent, with that opposite being h1 and the adjacent being 1. So the area of this one we know is tangent of x over 2. Now we go to the second one. Well, it's a sector of a circle, and the central angle is x, and that's out of 2 pi for the whole circle. And then the area of the sector would be pi times the radius squared. Well, the radius is OC or OA, they're the same. So the pi's cancel, and we're left with x over 2. And then we have the last triangle. The last triangle, the radius OC is 1, but OA is also 1. And OA is the hypotenuse for the triangle that H3, it'd be ADO, and OA is the hypotenuse. So we can actually say that the sine of x is equal to H3 over 1, which means that sine of x is equal to H3. So the area of that triangle then would be 1/2, the base is 1, and the height is sine of x. So that's sine x over 2. All right, now I'm going to go ahead and erase this so I have more room in here. The next step is to multiply every term, every one of these by 2, which will give us tangent of x, which we can rewrite as sine of x over cosine of x, is greater than x is greater than sine of x. Okay, and then next, because we know we're dealing with 1 here somehow, so if we divide every term by sine of x, then we're going to end up with 1 over cosine of x over sine of x, and sine x over sine x would be 1. Now, the last step we're going to do is we're going to invert these fractions and reverse the inequality symbols. That's a property of proportion. So this would be cosine of x. This will now be less than. This will be sine x over x. And this will still be 1. So now the cosine of x, the middle term goes between the cosine of x and positive 1. And because the drawing shows the angle x to be positive, but it's less than 90 degrees, less than pi over 2, we know that the following inequality has to be true. The cosine of x is 0 less than x less than pi over 2. Okay, so we know the angle has to be between 0 and pi over 2. Then the next thing we do is we're going to look at the left-hand and right-hand limits. So the right-hand limit, as x approaches 0 from the positive side of cosine of x, is going to be less than or equal to the limit, as x approaches 0 from the positive side, of sine of x over x, is less than or equal to the limit, as x approaches 0 from the positive side, of 1. Well, this is going to be 1. And this is what we're trying to find. And over here, cosine of 0 is 1. So then by the squeeze theorem, if this is 1 and this is 1, then the limit, as x approaches 0 from the positive side of sine of x over x is equal to 1. All right, now we'll do the same thing for the left-hand limit. So if x is a negative angle, then we would have sine of x over x is equal to sine of negative u over negative u, which is equal to minus the sine of u over negative u, which is sine u over u. Okay, that was letting x be equal to negative u. So then if we substitute x back in, we get that it's going to be sine of x over x. So the limit as x approaches 0 from the negative side of sine x over x is the same as the limit as u approaches 0 from the positive side of sine u over u, and that's equal to 1. All right, so since the left hand and the right hand limits were both positive 1, then we know that the limit as x approaches 0 of sine of x over x is equal to 1. And we're going to use that fact to solve some of these next problems. All right, so I'm going to write that again. The limit as x approaches 0 of sine of x over x is equal to 1. So 101.1 says find the limit as x approaches 0 of the sine of 4x over x. Well, if this and this were the same, if the 4x and this was 4x also, then this theorem here would apply. But they're not. So what we can do is we could multiply this by 4 and this by 4, because that's just a form of 1. So then this would become, this 4 can come out in front because it's a constant. So 4 times the limit as x approaches 0 of sine of 4x divided by 4x. Okay, so this limit right here, this thing here is going to be 1, isn't it? So the limit will be 4 times 1, which is 4. And if you graph that, you'll see that it does in fact approach 4 as x approaches 0. All right, one more for this lesson. Evaluate the limit as x approaches 0 of x divided by sine of 47x. Well, the limit of the reciprocal is the same as the limit of the function because the limit is 1. So if this had a 47, then this 47x and this sine of 47x would cancel out and this would become 1, correct? Well, it doesn't, but we can multiply by 47 there and divide by 47 here. Okay, so this 47 is actually going to come out here and be 1 over 47 times the limit as x approaches 0. Now we have 47x over sine of 47x. So this quantity right here becomes 1, and 1 over 47 times 1 gives us 1 over 47. Now you're welcome to look over the proof that's on page 519, but you won't be responsible for it. So that's the end of lesson 101.